Alright, let's get started. If you're watching this, I'm going to assume something right up front. You already know your way around a bench. You've aligned RF stages, chased oscillations, and spent hours wondering why something that should work doesn't. So I won't waste your time. What I want to show you today is a practical, buildable downconverter that allows a pre-war FM radio to receive modern FM broadcasts again. Not theoretically, not on paper, on the bench, in the cabinet, with real stations coming through. And yes, this works. Pre-war FM radios were not crude experiments. They were serious engineering, wide IF bandwidth, excellent audio potential, front ends designed with care. What failed them wasn't the design, it was history. When the FM band moved after the war, these radios were stranded, perfectly functional, but silent. This project exists to fix that. Not by gutting the radio, not by adding digital shortcuts, but by giving the radio a signal it already knows how to receive. What we're building is a frequency downconverter. Modern FM, 88 to 108 MHz goes in. Pre-war FM, roughly 42 to 50 MHz comes out. Nothing else changes. The radio's IF strip stays intact. The detector stays intact. The audio chain stays intact. We're not modifying the radio's soul. We're just moving the signal back into its comfort zone. This work is based on a circuit concept originally published by A.R. Mitz and shared publicly within the vintage radio community. That original concept made this entire approach possible. What I'm presenting here builds on that foundation with modern bench work. Corrected component values, real alignment experience, empirical station mapping, and documentation written for people who actually build RF hardware. Everything you're seeing has been tested, adjusted, and listened to. Here's the key idea, and I want this to be clear. We mix the incoming FM signal with a stable local oscillator. That produces new frequencies. We don't chase them all. We select the one that lands in the pre-war FM band and feed that to the radio. And here's where experience matters. This mapping is compressed. It is nonlinear. You cannot calculate dial positions. If you try, you'll get frustrated. This converter is tuned empirically, just like radios always have been. Let's walk the circuit from left to right. At the input, modern FM is coupled in very gently. Overcoupling here will cause more problems than it solves. The input inductor is 0.2 microhenry, not 12. That distinction matters at VHF, and getting it wrong will kill performance. The dual gate MOSFET does exactly what it's good at. One gate sees RF, the other sees the oscillator. The output network is tuned and lightly coupled, feeding the radio exactly what it expects to see. Nothing invasive, nothing irreversible. This is where most builds succeed or fail. The coils do not need to be perfect, they need to be reasonable. Air core, short leads, controlled coupling. And here's the rule that will save you hours. If something behaves badly, do not reach for the trimmers first. Reduce coupling. Always reduce coupling first. Alignment is straightforward if you respect the order. First, null the oscillator feed through. That's your quieting control. Second, peak the input response. Third, peak the output for clean audio, not maximum loudness. And do all of this with the circuit inside its enclosure. If you align it outside the box, it will lie to you. Once aligned, stations will appear, but not where you expect them. The dial mapping is compressed, it's non-linear, and it varies slightly from radio to radio. So we don't calculate, we tune, we listen, we write it down. That's not a limitation, that's radio craftsmanship. There's a moment when you tune across the dial and suddenly a modern FM station comes through a pre-war radio with wide audio, low noise, and real presence. And at that moment, you realize something important. The radio was never obsolete. It was just waiting for the right signal. If you enjoy bench work, if you enjoy alignment, if you enjoy making something old, work the way it was always meant to, this is one of the most satisfying projects you can build. It respects the radio, it respects the craft, and it gives you something you can actually listen to. This project is shared openly for discussion, testing, and improvement. If you build it differently, say so. If you improve it, share it. That's how this craft survives. If you've got a pre-war FM radio on your bench, this project is worth your time. Thank you for watching. Thank you for caring about these radios, and most of all, thank you for listening.